Hope you can hear me all. Very happy and excited to share our experiences related to agri-plastics. We have a lineup of experts today talking about this issue. I'll start the discussion with an overview of problems and potential solutions. Let me share my slides quickly. So hope the slides are visible to everyone. So again, welcome again. I will say, as Helena repeated, the session is available in two languages, English and Spanish. If you want to listen in English or in Spanish, click on this global icon, which is located in the bottom right of the Zoom control bar, and select your preferred language. Obviously, if you do not see a global icon, click on more, and there is 3 dots there, and make your selection from there. So let me start talking about this agriculture plastics. Is this a problem? And if this is a problem, what would be the potential solutions? To give you a perspective, agricultural plastics is very important for the food systems. Use of agriculture plastics is widely prevalent for several functions, several uses. For example, protective cultivation films, which is in greenhouses, tunnels, and plastic films. And sorry, below slides. Okay, nets and piping, irrigation, drainage equipment, packaging, polymer coated seeds and fertilizers, others, including silage films, fishing gears and other plastic use in aquaculture fisheries, including plant protectors in agriculture and forestry. And there are several unintentionally added plastics in agriculture fields, which comes from compost and sludge and slurry. Clearly, as we all understand, plastics is ubiquitous. It's a several uses in agriculture, and this is very important for agriculture, for better management of agriculture production, for increasing yield, for crop protection, and for reducing the use of inputs and irrigation. So it's not like we need to avoid uses of agriculture plastics. This plays a very important role, very important function. But how do we manage this is an important issue. Well, we see the trend in production and use of plastics for different uses in agriculture is growing. This trend currently shows, as per the data which was estimated in 2018 by the FAO, 12.5 million tons annually of plastic products used in agriculture applications annually. Now, clearly, there are some agriculture production systems where the use of plastics is, or different uses of plastics are much more, like in vegetable production, in fruit production, in livestock sectors. And in some countries, like Asian countries, which are consuming, as per one estimate, almost half of global uses of plastics in agriculture. Estimations available from OECD and other manufacturers data indicate that European countries are using about 1 million tons of plastics annually in agriculture fields. And for different countries, of course, the estimations range from 25,000 tons to 50,000 tons per annum annually. So the quantum of use of these plastics in agriculture is expected to increase by another 50% by 2030. So we are seeing an increasing trend of production as well as use of plastics for different uses in agriculture. What is this leading to? This is leading to what we call it microplastics accumulation. Ultimately, all the plastics that is used for different functions get converted into microplastics. And as we also know that most of this agriculture plastic is single use. And this can persist in the environment, in the soil, in the air, in the water that run off from the agriculture field after being used, damaged, degraded, or discarded. There was a project funded by EU Horizon 2020, and data indicate from there, which they investigated 70 soils across Europe, that almost like 0.1% of mass of soils in Europe in these samples. were containing microplastics. And recent study in the UK estimated that microplastic content of biosolids could result in equivalent of more than 20,000 bank cards worth of plastics being potentially applied on agriculture lands every month. So quite a lot of plastics have been detected, and microplastic has been detected in agriculture fields in different countries. And one estimation seems to indicate that soils are estimated to have more microplastics than currently oceans. Ocean plastics is getting a lot of attention, both from policymakers and investors and also philanthropic funds. But agricultural plastics, as of now, receiving less attention. But we know that microplastic accumulation in soil is increasing year by year. Well, does it has any consequences? Yes, there are economic, human health, and environmental impact of this microplastic accumulation. I mean, there are some scientific research estimations being done that microplastics reduce photosynthesis by 7 to 12 percentage because it lowers the chlorophyll content. And if it is reduces photosynthesis, obviously it will have an implications for reducing the yield of different crops. There is there is some estimations done in terms of accumulation of microplastic reducing seed germination and plant growth. And then the plastic resins, which are phthalates and bisphenol, contain toxic additives, which is also one of the important issues to be understood, which are having endocrine disruptive properties. So another estimate says that life cycle GHG emissions from plastics could reach, it's just not agriculture plastics, plastics overall could reach 15% of global carbon budget by 2050. So this is an issue to be seriously considered as of now. But then we talk about what is the data available around these issues, in terms of how much pollution agriculture plastic is causing and how much impact, environmental, economic, and health impact it is causing. So the data obviously needs to be related to the plastic value chain, as we call it, from trade, production to consumption to waste generations to plastic waste treatment. Because once the waste is generated, it gets released into the soil and into the different environments, and obviously it needs to be addressed as well. The issue here is that there is very limited understanding of the extent and severity of the problems in different hotspots and different types of agriculture production systems currently. And there are significant data gaps in the pathways and impacts of plastics, understanding what impact it might be causing, and also understanding are there biodegradable or alternatives used that can be promoted. Because countries are not publishing data related to plastic production, consumption, trade, and waste generations, there is some data estimates from OECD, mainly a few countries, which are providing some estimates on production and how much of that waste management is leading to being recycled. However, there is very limited data on chemicals in terms of their toxicity and what could be the impact of those in terms of endocrine disrupting possibilities. So data scarcity is one important issue here. Are there collection systems in operation? I mean, we have some mixed news here. Only a small proportion of waste generated is collected or recycled. The rest of the plastic waste is found scattered in terrestrial and aquatic environments. And there are, in fact, as I said, there are some good practices in European countries related to agriculture plastic collection and recycling systems. We'll hear about this from the expert panel here from Pierre related to France experience. And so Pierre will talk about more on this, but there is also EPR schemes and regulations which are effectively designed and enforced in some countries. We hear several examples from Canada, New Zealand, Norway, France, UK, and other countries. So there is, especially in developing countries, there is only a small proportion of waste collected, but in some countries in Europe and in Canada and others, there is a waste collection from agriculture fields happening. But there is also a lack of inadequate recyclability thinking in most product design. Global estimate indicate that less than 10% of plastic waste as a whole was recycled in 2019. There are solutions, of course. There are solutions like high thickness and high strength mulching films, which are greater than 20 micron meter. But these solutions are applied in only in few countries. There are no standards as such. There are some EU standards and some standards in China, which one of the panelists will talk about the China experience here today. So we clearly need an effective system for managing plastic waste and for improving recycling possibilities. Obviously, more finance and investment in research and development is needed for making products recyclable. Clearly, also on the cost-effective and scalable alternatives to agriculture plastics. I mean, we need to be careful here in terms of what is cost-effective alternative, what is viable alternatives, because we know that in many cases, requirement of biodegradability with related to temperature, humidity, etc., would require industrial composting infrastructure. So it's not biodegradable in every environment. It's biodegradable in controlled conditions. So clearly, that's also an issue which requires further research and further financial support to innovators and businesses. There is inadequate regulation and standards for plastics. There is currently no overarching international policy or legislative instrument that addresses all aspects of use of plastics in agri-food value chains and throughout its life cycle. We hear a lot of examples of ban on single-use plastics, not specifically related to agriculture plastics, and more generic ban. But we have also heard about how this ban enforcement is a major challenge. We also hear about mulching film standards, EU standards related to mulching film thickness, and also EU standards related to polymer-coated fertilizers, which are, beginning to receive some attention from the policymakers and regulation. There are examples coming from China and EU. In the UK also, there is very less realization or recognition of controls of new hazards, including microplastics in the current agriculture regulation. Even though we know that FAO has developed in the last few years a voluntary code of conduct for sustainable management of which is a very important document and guidelines for the government and for the private sector on sustainable use of agriculture plastics. So finally, do standards exist for the recyclable products? There is an EU soil monitoring directive which is being amended in terms of including the monitoring of microplastic presence in the soil and in terms of plastic chemical additives and low plastic content certification for biofertilizers. And also there are some, as I was talking about, biodegradable mulch standards, which are being developed in some countries, but in general, there are much more work needs to be done in this area. Clearly, supportive regulation and voluntary mandatory EPR schemes would needs to be developed in several countries, including developing economies. So I will stop here and hand over to Pierre to share very specifically the France experience, which is an exemplar in this field of managing agri-plastic waste. Over to you, Pierre.
Thank you very much, Ravinder. It's my turn to share my screen. I hope it works. Yes, good afternoon, ladies and gentlemen. I am Pierre de Lépinau, based in France. I am an agronomist, and I worked during 15 years in crop protection industry, and then joined as a founder and a general manager the EPR scheme for agri-plastic, which has been founded in 2001 in France. For 2 years now, I joined the Agri-Plastic team in Office of Climate Change, Biodiversity and Environment in FAO, and I fully support and I advise the plastic team for different various projects, such as the voluntary code of conduct, but also the farm project, mainly in Kenya. So I'm delighted to sharing with you my experience regarding the development of an EPR scheme in France. So these are insights from 20 years of practice, but not only in France, because during these 20 years, I was very close connected with other countries, mainly in Europe, but also in North America, Canada, the US, and South America, like Brazil, Argentina, and Chile. And I don't forget New Zealand and Australia. My first slide is just to present you the key figures regarding the use of agri-plastic and the management of agri-plastic in France. The last estimated that around 125,000 tons of agri-plastic products plus packaging are placed on the market annually. France is the third or the fourth country plastic user in agricultural sector in Europe. The first one is Spain, the second one is Italy, and third one could be Germany or France. The main user groups are 300,000 farmers, mainly livestock growers using silage wrap nets and twines, and the other group is horticultural farmers using mainly mulching film, tunnels, plastic tunnels, greenhouses, covers, and nets. The key program milestone are 2001, the launching of the voluntary initiative, focusing at the beginning on pesticides packaging, and then step by step was enlarged to other plastic products. Between 2005, yes, and until now, the scope of the scheme has been expanded to all plastic packaging and products used in primary agriculture. Starting on 2010 until now, new capacities, new infrastructure of recycling has been developed. Keep in mind that most of for all the agricultural plastic, you need specific recycling process. So that means that you have to invest on specific line in an already existing recycling plant, or you have to create new plant. More recently, 5 years ago, the French scheme started to promote eco-design and to push manufacturers to increase the incorporation of recycled content. So to summarize, 25 years of development and eco-design of products, yes, could be developed when the system is very mature on a technical point of view, on an economic point of view, and need very close connection with the private sector. What are the key indicators regarding the efficiency of the scheme? And these data are addressing the results last year. 8,000 drop-off stations, so there is a very close drop-off station network in the country. We will back to this issue, but it's very important and to help the farmers to change their practice and to implement drop-off station very close to the farms. 25 waste streams are managed separately. This is probably one of the key factors of success. That means that all the farmers has been trained to sort their plastic waste, and because these wastes are sorted, it's possible to recycle most of them. Keep in mind that there is very few, nothing to do between different kinds of plastic. For instance, if you consider HDPE rigid plastic, which is the resin used for plastic containers, for pesticides or liquid fertilizer. Nothing to do with plastic film used for mulching, for instance. And furthermore, the plastic used for mulching film is quite different than the one used for silage bale, for instance. So if you consider the needs of the recyclers, they are very uncomfortable if you deliver some mixture. So they ask for very pure stream in order to get an efficient recycling. So of course it takes time. It needs a lot of training, first on farmers, but it could work. And this is the case currently in France, but not only in France. The collection rate on average reached last year 79%. It's on average because if you consider, for example, pesticide packaging, the collection rate for plastic packaging is over 90%, 95%. The same thing for mulching film, for example. So it depends on the plastic, but it depends of the date of the launching of the program. Older the program, better if the collection rate. And last but not least, 90% of collected plastic are being recycled. That is mainly because all the plastic are sorted on the farm by the farmers. So with this this result, what are, let's say, some conclusions based on my experience in France, in Europe, and in other developed countries? I have selected 5 key factors of successes, which, according to me, does not depend really on local condition. I think it should be considered as guidelines for most of the countries, probably included developing countries. First, you need a pilot experiences. It's very difficult to launch a collection system, an EPR system without any experience. Technical experience to develop farmers' good practices, collection operational procedures, and to have a clear estimate of cost, because of course, most of these systems are quite expensive. Second key factor of success is the support of the brand owner's leadership. It is clear that successful implementation need the full support of the brand owners. It was very clear and very helpful for pesticide packaging at the beginning, but also for plastic films, plastic twines, and so on. For these brand owners, implementation of collection scheme are aligned with stewardship commitments, so is a part of their own policy. Furthermore, they bring technical know-how, for example, how to recycle packaging which has contained hazardous goods like pesticide containers, or how to recycle and to reuse, let's say, to incorporate recyclates in the product. These are closed-loop recycling systems. We start closed-loop recycling system 5-7 years ago with the main plastic film brand owners. Third factor of success is the farmers' involvement. It's very important to involve the farmers in the governance of the EPR scheme or national collection scheme. It depends on the context, but also across a multi-stakeholder dialogue for each agri-value chain. The issue, the concern are not the same for milk producers, for fruit growers, for vegetable growers, and so on. So it's very important to have very close relationship and multi-stakeholder dialogue with these agri-value chains. Cost coverage is very important. The system must be sustainable on an economical point of view. And we know that during the last 10 years, the economical condition for recycling, for collection, was not very stable. So you need to have an income coming from the EPR scheme to secure and to make the system sustainable. And last but not least, collection network design. As I previously say, you need local drop-off station, mainly for small and medium-sized farms, on-farm collection or direct recycling plant delivery system is possible for large farms. Other key successor factors which are less dependent on local contexts are mandatory EPR requirement from the national authorities. You have to know that even in Europe, with let's say an umbrella regulatory framework, the system, the requirement regarding EPR are very different country per country. So it depends on the policy design by the Ministry of Environment most of the time, but sometimes also by the Ministry of Agriculture. Another point very important is to know and to have a clear assessment of what are the recovery pathway aligned with local waste regulation. Same thing, thanks to my experience in Europe, the regulation are quite different country per country regarding interpretation of the classification, despite the fact that we have only one EU regulation, also for transport, storage, or final treatment routes. The choice of partners for collection could be very different country per country. It could be distributors, municipalities, waste company, or recyclers. And finally, cross-compliance requirements. It is clear that certification programs helps to develop efficient collection program, and this certification could be national, could be regional, and European policy could help also. This is the case with the actual common agricultural policy, which sends subsidies to farmers who take commitment regarding their management of pesticide packaging, for example. And more recently, the EU has implemented the eco scheme. And in some countries in the EU, these eco schemes are used to give fundings to farmers who has clear commitments regarding their plastic waste management. But there are still issues under development. The main topics are the harmonized database, which is still under construction, and there are some pilots developed by European associations such as EPRO and EPA, which represent the agri-plastic manufacturers. We have now to implement the packaging and packaging waste regulation, which entered into force on February this year, which include agri-plastic packaging, but now we are waiting for dedicated acts and compliance measures. And last but not least, there is a project to implement a specific regulation framework for non-packaging agricultural plastics. This project is led by the DG Environment and will start this year with an impact assessment study. We expect for potential entry into force in 2028 to 2029. So as main conclusion, just to underline that according to my experience in France, but not only in France, in European country, or let's say in developing countries, it is clear that agricultural sector is a unique sector, so need a specific approach and specific regulation to support sustainable use of plastic in agriculture. That's why the voluntary code of conduct supported by FAO will be probably one of the key pillars to support such policy. The other conclusion is that we have only until now very poor experience in developing countries. And I hope that the project and the development in Kenya, the FARM project, with a component addressing agri-plastic issues, will be very helpful to define first some guidance and good practices to support the effort of countries who would like to implement efficient policy addressing sustainable use of agri-plastic. I thank you for your attention, and I remain available for any questions. Thank you very much.
Thank you so much, Pierre. Your talk has generated a lot of interest and questions as well. We'll come to that later. Mr. Zhen, over to you. If you can focus your slides on the perspectives, and because we have only 8 minutes for your discussion. Thank you, Professor. Over to you.
Okay, so you guys can see my screen, right?
Not
okay,
yet.
So
Not
it's my pleasure. Not yet. Oh. I think I have sharing my. I'm sharing my screen.
You can see that now.
Okay, good.
Go ahead.
So it's my pleasure to join this webinar for the FARM project. So my title is Semi-Quantitative Analysis of the PE impact soil by ATR technique. So I'm Zhen from Nanjing Agricultural University. So the first part I would like to remind you guys is that the utilization of the PE, the mulching film, impact soil is increasing significantly every year. So the average rice, so first in Asia, many Asian countries, the average rice yield increased every year, and nearly 30% of the demand for plastic polymers, is assigned to the rice yield. So the estimate is that the global mulching firms is around 5% every year. And recently in China, we have a data here, almost every year, 30%. So I would like to, let's say, the mulching film in paddy soil in China, at least, is still, just a low concentration. Only low concentration of the farms are using these films, but the increasing rate is very, very quickly increased. So the microplastic remain, so that is main problems in paddy soil, I think in the future. So we have many techniques to solve this problem. Everyone can see that, for example, the physical method, chemical method, or biological method. There are some negative impacts, for physical and chemical techniques. And many people would like to solve the problem based on the microorganisms. We call it some biological technique. So then what we currently do in our lab, first we are not chemists, we are soil scientists. So the first thing we would like to do, and also it's the main project today, I would like to share with you guys, is that we want to find a quick and very low cost technique to quickly estimate the microplastic in paddy soil. So as we know, we have the optical microscope, we have the SEM at a micrometer scale that we call the physical method to identify the film, microplastic in soil systems. We also have some other technique, for example, the thermal analysis, but we also have the spectral technology, for example, ATR, IR, or we call it FTIR, or Raman spectroscopy, and maybe also other techniques. And today we would like to, in our lab, what we do is we use the ATR, IR. I think this facility should be kind of common to many guys in the lab, because this machine, should I say, is kind of, I mean, relatively cheap. I mean, compared to SEM, TM, many fancy machines. So it's very common machine. And what we do in our lab is first we collect the microplastic from the paddy soil. This paddy soils has been planted rice and used the mulching films during the planting. And after the harvest, we collect the sample from a dry site and a humid site. So what is the dry site is that the area is kind of low humidity and low water. And for the humid site, you can see it's usually at kind of low and has more water. And also the second thing we call this the parallel experiment. We use the in-lab simulation. That is, we add the PE into the soil systems and to just simulate the PE pollution in soil system. For both of the samples, we collect them and we analyze them by ATR-IR, this technique. So I should say it's not very new, but not many soil scientists started to use this technique to quantitatively estimate the microplastic in soil system. And when we look at the results, we can see it's very functional. For example, this ATR-IR spectrum, we use the ATR to study the PE particle itself. We buy the pure chemicals, PE particles. We can see they have a very strong and characteristic peaks. And we use the ATR to study the plastic mulching film. We can see they are just the same. That is because these mulching films are actually, I mean, made of these PE particles. So that is straightforward. They are the same thing, just a different morphology. And then we also studied, we mentioned that we collect the soil samples from the paddy soil. This soil has been used, the mulching film, so they have some film fragment in soil system after harvest, right? And we use this, we collect them, and we use ATIR, start them again, so we can see they have the same peak. So that is, we can confirm, yes, there are many microplastics, I mean, due to the PE application and PE mulching films. And we also do some detailed work, and maybe not many details I can share with you guys later. So the quick conclusion here is for the for the humid area, I mean, that's high water area. So we can see more intense peak for the plastic seams. For the dry area, we can see relatively low signal of the plastic particles, PE particles. So I just remind you guys, all these spectra has been normalized, so we can compare the intensity. So we can see for the dry area, the sunlight is very useful for the for the decompose the plastic particles. And the second thing is we also used as we mentioned, we used have a parallel experiment. We add the different PE microplastic into the soil with different concentration from 0%, 0.25%, 0.50%, and then finally arrived to 2.50%. So we have a very a series experiments. We can see the peak for the microplastic, I mean the characteristic of the PE particles. Let's say the 1473 peak. We can see the intensity of this peak just increasing very gradually, right, and very smoothly, just smoothly increased. So we can confirm, yes, ATR is very powerful. Although this is a very easy technique and a very low-cost technique, but it's very functional to estimate how much, I mean, PE plastic mulching film left in the soil systems. And
Mrs.
we also
Zhen,
do the
Sorry to interrupt you. Sorry. Can we just wind up because the time is getting completed. So
Yeah,
maybe
yeah,
last
I'm just
couple of
coding.
minutes. Yeah,
No problem.
sorry.
So we also have the more detailed to predict the content. I mean, finally, estimate how much precisely how much film left in the particular soils in the soils. So the answer is very straightforward here. In the humid area, we have more plastic, and in dry area, low plastic left. So it's just consistent with our previous analytical results. And this is possibly the final version, final slide of my today's talk. So we would like to do is the biodegradation. I mean, based on the ATR technique to estimate how much we left. We would like to next step. We would like to screen more microorganisms. They use secretion of the extracellular things and to increase the decomposition of these plastic things. And also for the future directions, I should say first material, we would like to have more functional microbial strains. And the second thing is for the standards, as the Ravi just mentioned in the beginning of today's talk. We actually have started to create the first standard in Jiangsu province application of the functional microorganisms. So next step, we would also like to work with you guys to have more standards related to the microplastic remediation. Okay, so I think that is my final slide. Uh, I hope we can, in our group, based on the fungi, mineral, and fertilizer system, to solve the agricultural plastic issues. So thank you. That is my talk.
Thank you so much, Professor Janley. I mean, this is very interesting experiment and also showing the possibilities of future work that is needed for making biodegradable mulching films. It's one of the successful experiments ongoing in China, which we can learn from. There are several questions which have come from the audience related to the talks that have already been delivered. Do we have another speaker, Marisol, in the audience, or not? If not, then we can proceed with the question and answer session. I guess not. So I think it does provide us almost 15 minutes for Q&A. So thank you so much. I mean, there are several questions, as I was saying, raised. Very interesting point of views also related to, what technology is successful and how much development of that technology needs to be done. One of the first questions I will take is from Laurie Fisher. She has asked Pierre very specifically related to the cost of recycling. How much is this funded by the farmers? Who is funding this collection centers and recycling? How does this France experience indicate in terms of the cost of operation? Over to you, Pierre.
Thank you, Ravinder. Yes, I sent an answer in the chat. The situation is quite different depending on the country. To summarize, let's say that in most of the countries with already existing scheme, the collection for empty packaging is free of charge for the farmer. That means all the costs are supported by the manufacturers, or let's say manufacturers or importers, depending on the country. For plastic film, or let's say plastic products, it's quite different. Most of the countries are asking for a fee to be paid by the farmer, additionally to the fee paid by the manufacturer, because of the cost, the cost of the recycling much higher regarding the price of the product. So it's really a question of different economical model between plastic packaging and plastic products. When you have to pay a fee for plastic packaging, the cost of the packaging is only 1 or 2% of the cost of the total product. So you pay for a cost linked with only 1 or 2% of the product at the end of life. On the contrary, when you are dealing with plastic product, the product will be the waste. I mean, 1 kilo of plastic film will be 1 kilo of plastic waste, and sometimes much more than 1 kilo. It could be 1.5, 2 kilos because of the contamination and the moisture. So the costs are much higher. That's why in France, collection for plastic products are free of charge except mulching film, because the costs of recycling from mulching film are much higher. In other countries with already existing schemes, such as Ireland, Germany, Canada, there is a gate fee to pay by the farmers, additionally to the fee paid by the manufacturer.
Okay, I think connected to this and very intriguing question from an anonymous attendee. So he or she is asking that how can EPR be successful in CIDS country? We know small island developing states are the countries which are importing most of the plastic used in agriculture. So clearly manufacturers are not there in the country to pay for it or to ensure the recycling or to include in the EPR mandatory or voluntary. So how do we tackle it? Any comments from Professor Janley or Pierre?
May I start? Perhaps regarding the EPR principles, it's very clear. If there are no manufacturer in the country, it should be the importers to support, to finance the EPR system. So it's very clear. And let's say if there is a licensing system, it will be very easy to control and to push the importers to finance the EPR. The point, the concern is there any licensing system to import plastic? Until now, in most of the country, the answer is no. And so this is one of the guidelines included in the voluntary code of conduct supported by FAO. Is perhaps we should have licensing system to have a clear inventory of who are the importers of agri-plastic in each countries.
Okay, that's great. I think obviously this requires much more discussion, which we will open up in the Green Forum, and we'll talk about that in the Green Forum, Agriculture, Agri-Plastics Community of Practice later on. But this question is for Professor Zhen Li, related to the biodegradable mulching films that he's experimenting with, and also obviously conventional mulching films, rice fields. Is there a price difference in these two type of films, and what could be the barriers for farmers to adopt biodegradable mulching films? What is the experience in China says?
So the price, yes, for biodegradable films, at least in China, the price is almost doubled, I mean, compared to the conventional films. So that is a big problem. I mean, even people said, okay, this is biodegradable, so it's more. I mean, it's more it's better for the sustainable agriculture, but for the farmers, so they must consider how much they can earn after the harvest. So yes, the quick answer is doubled. So it's actually significantly limit the application with the biodegradable film. And also, there's a potential problem I would like to remind when we talk about the biodegradable, it's actually many times we think it's just decomposed to the, I mean, finer particles, and it's still plastic particles. It's still not decomposed. So when we think this completely decomposition is that it finally becomes, for example, CO2, methane, or other things. Then finally, not just the finer particles of the plastic. Okay.
Okay, there is a subsequent questions from Dr. Nazakat Ali Kwaso, maybe again addressed to Dr. Professor Zanli, which is looking at, how do we overcome the adoption issue? I mean, you're talking about limited adoption because of the price factor or maybe other factors. So how can the FAO EPR policy or national government EPR policies and regulations support increase in adoption of bioplastics or biodegradable alternative uh, material for different uses in agriculture fields? This is Lee first, and maybe Pierre wants to come in also later on.
I think I'm not familiar with the EPR thing, so maybe other guys can help to answer this EPR thing. And some
Okay.
Pierre maybe good at it.
Yeah, Pierre, over to you.
Yeah. Regarding biodegradable, on a technical point of view, I'm not so comfortable because I think we have still some knowledge gaps to fill and to know exactly what happened for this during biodegradation and what will be the becoming of the plastic. Moving to the economical statement. As Professor Zhen Li said, the cost for biodegradable is twice higher than compared to conventional. But if you consider the total cost, we life of a conventional plastic, then the situation is different. And this is one of the benefits of an EPS of the end of life. Consider mulching. The cost for recycling of mulching thing is that the biodegradable is not 1 to 2.
Your voice is breaking.
Euro, and that's what
Okay, I think we lost voice from Pierre. This is with me only. Not sure, but I will raise another questions from the audience here, which is from multiple audience actually. People are interested in knowing about the recycling infrastructure. So Mohammed Afleet as well as from Laurie Fisher again. Because recycling infrastructure, the cost of establishing that infrastructure, and then also because we know this biodegradable alternative material is expensive than the conventional material used in agriculture fields. So, but then conventional material has to be collected and recycled. So there is a cost associated with that as well. Is both things ultimately, if we look at life cycle analysis or also cost effectiveness analysis, both things will tie up. Establishing infrastructure might be more beneficial than using expensive biodegradable material or vice versa. I don't know. I mean, Pierre or maybe Professor Zanli later on can come in here.
Yeah, I would like to have a comment additional to the Ravi's just the quick answer. So yes, the quick answer for the cost of the infrastructure, is that more expensive? Yes, I should say yes. I think the one big problem is the collection. I know in maybe in US or in many big farms in EU, maybe I mean the farms are very huge. So maybe one farmer has a big area, so they can collect. He will just collect his farm. That's the work be done. But in China, one farmer maybe have a very limited area. I mean, let's say it's very tiny farm, maybe less than 1,000 sorry, just 1 hectare. So the problem is the government or the infrastructure should pay more attention and have more efforts to collect these films together. I mean, maybe for the final degradation or just to collect them for other use. So that is also very expensive thing. I mean, for the collection of the plastic or film left in the soil.
Ravinder, just for a comment. Sorry, I think I lost you, but I'm back. You are talking about the cost of infrastructure for recycling. That's it, correct? Yeah. It's true that under European conditions, the costs are very, very high, and let's say higher and higher due to environmental regulation, especially regulation addressing the treatment of water, because there is really a concern regarding the water used in the recycling process and how to limit the quantity of microplastic in the water. It's really a concern. So it's very expensive under European condition. A very interesting experience is coming from Morocco. Morocco has some pilots in south of Morocco with mulching film with very, very competitive cost. And I think this experience has to be monitored. I know that there is now a new step in this project is to build one single industrial plant to control the quality water, the quality water, because this is also the concern. But the costs are much more competitive regarding the market conditions, and it's mainly due to the quite low cost of workers. You need hands if you want to retrieve mulching film and to get them quite clean. You need a lot of hands. Hands in Europe, you know the story, very expensive, much cheaper in developing countries, but it could be considered as an opportunity. I think it will, I am convinced that it will be much more simple, let's say easier, not simple, easier to recycle mulching film in such country than under European condition. And that's why the experience in Morocco will be very interesting to monitor and to assess. But well, perhaps there are other experiences in other places. I don't know.
Yeah, I know there are several experiences which we heard today. Very interesting talks from Professor Zhen and from Pierre. And it raised a lot of interest and questions today. We have completed our time for today's webinar, but we invite all these questions, these are important questions we cannot answer within the time frame limit of the webinar, but we invite all the participants to come to the Green Forum. I think the link will be shared with you. So there is going to be a community of practice on agricultural plastics where such experiences and such important insights about ongoing initiatives and inspirations across the world will be shared. So with this, thank you very much for everyone's participation, and I'll hand over to the organizers to close the meeting. Thank you.
Thank you for organizing.
Thank you, Ravinder.
Thank you.
Pierre and Professor Zhen and everyone who comes to today's webinar. Once again, we would like to encourage you to please continue this discussion in the Green Forum. The link is posted in the chat, and all the speakers will be available until the end of next week to answer all the remaining questions that you might have, and also additional questions that you might want to discuss with them in the next coming days. So thank you again, and enjoy the rest of your day. Thank you very much.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you.
Thank you. Bye-bye.